All right, cool. I guess Will's kind of introduced this one. Yeah, I'm just going to highlight like the one big line at the bottom, right? Which is, how long should it take to get your code into production? I'm just going to seed that there while I introduce myself. So, my name is Gates. I'm a senior principal engineer. I've worked at Roblox for about 4 years. I spent some time on the trust and safety platform and this microservices platform with Will. I've been in the industry for about 18 years. I've done lots and lots of startups. If you like either of these sites, come talk to me afterwards. We can have a chat. I write on other people's sites. I don't have my own blog. But I'm a big distributed systems and databases nerd, so this is the stuff I like to talk about. I'm going to open this before I jump into history a little bit. Let's open this with these little questions for ourselves. What if you could ship a new service in a half a day? From zero to a new service, and production ready. Charts, logging, keys, metrics, just everything, right? Maybe it just says hello world, but like it works and it runs in your infrastructure. And then what if you could ship those changes to that in a half an hour? So you go in and add a new endpoint, and you hit the ship button, and it's there, and it's in production, and it took less than 30 minutes, right? I'll get back to this slide in a little bit, but let's just keep that in our mind as we start working through the development loop at Roblox. I think people have seen this picture. I mean, I cribbed this from Hacker Noon, but like we've all kind of seen this, infinite loop here somewhere of building and testing and releasing and going back and planning new stuff and going through the whole cycle. If I make that square into like this, I make that loop into like a square, it looks like this. We're not going to talk about all this stuff today. I'm just going to focus on kind of these four in the middle, right? Which is the build, test, release, and deploy. Apparently I hit the wrong button. There we go. So let's go back in time again to 2012. We've done this a little bit. I think it's important to note that like Toby joined in 2012, I joined in 2016, and then Will over here joined in 2018 as we look towards the future. So these are all kind of snapshots in time from like when we jumped into Roblox. And so at Toby's time in 2012, we had 15 web engineers, literally 2 ops people, 1 public website. Right? And I mean, this is our deployment right here. So yes, that's the Visual Studio 2010 logo. And how do you build the thing? You hit the F6 button, you get a build that's on your laptop. Great, how do you test it? You bring your friends over, you test it on your laptop. And then how do you release it? You take it from your laptop and you put it on the server. And once it's on one of the servers and it's running, you run this little PowerShell script and it moves it to the other servers. So yes, it is this and then that. And hey, look, you're in production, 100 machines. It's great. Except it has some issues, right? The obvious biggest ones are just it's prone to human error, because if somebody fat fingers something or takes the wrong build, or I take my build instead of Toby's build, bad things happen. The other challenge is we're releasing every 2 weeks, which is a long time. And frankly, there's a lot of changes. I mean, even with 5 to 10 people, if you're committing one thing every couple of days and you add that up over 10 business days, suddenly you're shipping, 25 changes at a time. And that might not seem like a lot, but when you're trying to debug which of those 25 changes actually is causing your production to go down or is causing your caching to go bananas, this becomes a big deal. So I drop in 2016, and we have a lot more people. We have 40 of these guys, 40 web engineers, and we've got 4 ops people, so we're getting there. But you'll notice this big change is the sites, right? We have multiple public sites. We're supporting the mobile app now. We've got internal sites because we have to have an admin site and manage stuff and customer service. We're starting to break that monolith out. We've got these services. We've got these processors that are running in the back end, but there's a few dozen of them. We kind of know what they all are. And the good thing we've done is we started to add automation. So if you look at this time period, all these things there's less humans. They're getting better, right? So the build step, we've got builds running through TeamCity. We've got these little bat files that run. So you hit the build bat file, and it runs and builds the whole website and all the other services. It gets deployed onto this test environment. So we have these wonderful test environments, which are like miniature clones of the big website. And then Selenium runs on them. Yes, those are humans. We still have humans running stuff on them as well. But when that's all done, finally TeamCity actually puts it onto a big disk somewhere, and then this happy fellow on the right, the deployer, can actually deploy stuff. I want to zoom in on this little happy fellow on the right here for just a little bit. because this is actually something kind of cool. I call this the deployer. So again, this is 2016, so we're talking about like 4 years ago. And how do you deploy multiple services onto hundreds of machines? Because that's where we're at, right? There's 30 services, and we need to pick what's going where. So this is actually what this looks like. There's a lot of information on this page, but I think the key thing to look at is that top left here. Is there a laser pointer? There it is. Is that top left over there where you see like, hey, I've picked which service. I want to ship text filter. That's the only thing I care about, right? And I've got all this information about where I'm getting that build from, and it's going to production, and I've got this validation server, right? So I've decided, hey, this is one server, and that server is going to be the server that I'm going to start deploying on. Many of you might be familiar with the term canary deploy. We called it validation server because we didn't know what a canary deploy was in 2015. But this is kind of this basic thing, and then on the right here you have this whole like, here's a history, right? Cool, here's what's going on. And you've even got the like, oh my god, stuff is going terrible button. You can hit the abort if everything goes bad. You can hit rollback if everything goes bad 10 minutes later. You know, you can requeue stuff if it failed for reasons unknown. So there's a lot of cool features at this point, you know, and you can even go into a single service and figure out the history of this one service. So you can see this text filter had some issues, you know, and then eventually we got it sorted out and we got the thing deployed. And you can even go into a single build, and the single build is really cool, right? I can literally look at like, hey, every single individual server and what they did and get all the logs. I want to highlight that little green thing over there. We're going to get back to that in just a minute. At this point, you know, dropping in 2016, this was actually pretty cool. We could deploy a lot of stuff. I could control when my thing was ready to go to production and then actually like watch it ship. But it does have some problems. I mean, this is, that's 17 of 17. So that was 17 servers, and it took us 21-ish minutes to get that thing out, right? In fact, if you drill into it, on the right over here, that's 2 to 3 minutes per server to get a server going. And again, like, we're talking about 20 or 30 services, and we want to start changing them every day, and you've got 40 developers. Like, waiting 30 minutes to deploy 17 servers. Well, when you get 500 web servers, suddenly this becomes like an all-day gig, right? So we got problems. Problem number one is builds are slow. Remember I said we've got it automated in TeamCity? It was cool. TeamCity built everything, just every time. And suddenly it turns out that building everything every time is kind of expensive, but that's the nature of a monolith, right? You have to build everything every time. The test environments, they're getting really busy, and things start getting flaky. You go from like, hey, look, these 300 Selenium tests are going green, to like, the 300 Selenium tests aren't finishing because people keep deploying while I'm in the middle of running my Selenium tests. Releases became not atomic, right? The answer to all this building problem is like, well, let's just grab 2 or 3 check-ins at once and then build them so we don't get in the way of other people's deploys. But then you get the problem of like, cool, build 55 was good, but build 56 is failing. Well, what's in build 56? Well, my change and Toby's change. So now Toby and I are trying to figure out which of our changes screwed up build 56, and we don't know because the releases aren't atomic. And really just the deploys didn't scale, right? We could not throw more people at it because eventually the queue for deploying just literally took all day, right? And when you're like, I need to deploy 20 services because we changed something really core, you were like, okay, we'll all stay until midnight, right? And this is where we got into tightening the loop, right? Again, 2016 things were cool, but we doubled and doubled again, and suddenly you're like, 2018, things start feeling bad. We've got meetings, internal threads, you know, some frustrated product managers. It can take how long to do what now? And this became our big talk, right? How do we break up the monolith? And at the same time, like, how can I own my own code, right? Because people, like, I just cared about the text filter, and I didn't want to ship everyone else's stuff. I just cared about the text filter. So this is where we get back to this. We're sitting in a meeting, and I go, well, hey, look, what if you could ship a new service in a half a day? And what if you could ship a change in a half an hour? Would your team actually start breaking up the monolith? Would they start changing how they behaved? And that was kind of the moment where people really felt like, yeah, this will do things. So yeah, we built a team. So this is the team that Will and I founded. It's called Microservices Platform, established in 2019. And and this is what we put together. And this is really where this containerized kind of different self-driven universe really comes from. And so this is 2020. I want to highlight that like the numbers are all bigger, and they all look bigger, and we can all read those numbers. But the other big change that's really happening here is something we hadn't necessarily talked about yet, and that's this. You go from 1 team to 5 teams to legitimately there are 25 different teams in Roblox that have back-end engineers on them, right? And this really begets that like, I want to own my code. I want to own my stuff. Because 25 teams starts to feel like a lot of companies all at once. And really that becomes Roblox, right? That's actually who we are. It is a self-organization thing. It's literally on the mug. We want to self-organize. And to do that, you need to empower people to do their own thing. And now everything here is different, right? We are building in Docker. We are building stuff with drone. That's this little ball over here. And tests actually start to change. Because now if you can own your own code, you can use this little octopus here, which is the Docker Compose guy. And he can actually start orchestrating your tests for you, right? Because you're no longer running on everyone else's test environments. This octopus is setting up your environments for you, and then you get to run your tests in your environment and shut it down when you're done. Releases are a lot quicker, right? Drone, when he says you've passed your test, he drops you into Artifactory. And now everything's atomic, right? Because every check-in you have actually does this whole cycle and generates things. If 2 people have different merge requests, we can generate both of them and all of them and put them over here. And then we use Nomad console, and I've got Trafic and Vault off on the side. But basically this is, I don't know if you guys are familiar with Kubernetes. These are Nomad and console are very similar. This is like, it's like Kubernetes Lite, and that's like, you know, etcd type of thing, right? But basically we have these things, and they are container orchestration. So suddenly, if I am building containers, testing them, and then putting them in the stage to be released, Nomad can orchestrate all of this work and actually decide to ship containers to the right places and help us get this going, right? And it works with things like console and Trafic to say who's up, who's down. And this starts to change this answer, right? Because suddenly, like, I know where my stuff is. And the answer is, it's all in your repo. And we hear this term code as configuration a lot, but like, legitimately, this is a slightly modified snapshot of what that generated product looks like. So Will was talking about like, hey, you hit swarp, create new product. Like, this is what comes out. So if you want to know like, where are my alerts? They're there. If you want to know like how I'm building, there's your drone file right there. If you want to know what services you have or how Nomad is configured, all this stuff is here, right? You get to own the configuration that you are shipping into the universe. If you want to figure out how to get Python working, well, you know, talk to us, but like, we'll modify the drone YAML file and we can figure out how to get the right Python script working for you, right? Or how to get the right Python builds working for you. And of course, if other people want to talk to you, here's your README. And here's you. You're the code owners, right? This is you. So this really is a shift in how we view our own universe and how we view our own interactions with our code. And I want to be clear, by the way, like teams can have multiples of these, right? Many teams actually have 2, 3, or 4 repositories that they've created because they already can see like how ownership needs to be divided. Other nice change is builds are fast, right? Because we're no longer building everyone else's stuff. I'm building my stuff, my dependencies, my tests, only the stuff that I own. We also have more flexible deployments. Do you remember when I was talking about like the one canary deploy, that one validation server? One of the really interesting things about having one validation server is when you deploy 400 web servers, you don't actually necessarily know that it's really working the way you want it to, right? I mean, even if you're sitting there watching the charts, you're like, okay, I got 100 servers, I deployed one of them. Are the charts doing anything weird? Well, you deployed 1% of your servers, right? So you don't actually know if the charts are doing anything weird, right? That's where this thing comes in. Hey, look, I've got a canary number. I can control it. I can say, I want to deploy 20 things, but I'm not going to know if anything's wrong until I've got 5 of them out. And that's the way my service works, and I can own and manage that, right? So now we're empowering teams to do the things they want. All of this is kind of begetting what happens, you know, in the next few years, right? Because we have all this stuff I've shown you, it's all working, we can do this. Teams are already starting to migrate. And like I said, the answer is, hey, can you migrate? Well, yes, interns can come in and actually start migrating code. And it no longer takes months People aren't individually racking servers, right? You just have to get your stuff building and you can ship it. But we have other big problems. So stuff I look towards in the future and stuff that we're already talking about and designing for is like, how do you test with real traffic in production? Now, remember I told you about these test sites. Okay, we've got these test sites, these little microcosms, right? That's great. Somebody generated, 200,000 users sometime 5 years ago. 200,000 users is like a fraction of anything going through Roblox at any given time, right? It just doesn't do anything anymore. How did one of my testers put it? One of my testers said, we'll do our best to test it, but our users can do more testing in 2 minutes than we can do in a lifetime, right? And if you come from that perspective, then all of a sudden, like, you realize that it's great to be correct. Unit tests and component tests are invaluable. It is great that your code in some small sense works, right? We need to know this, but we also need to do things to start testing what it actually looks like when it's running. And this is where you talk about things like traffic mirroring. Can I set up a new service and actually have the same traffic go to both of them so that my new service can sit there and just run for an hour, a day, and just do nothing but log data so that we can ensure that this thing is actually ready to go to production? Can I do intelligent routing? Can I turn on a new service and say, hey guys, this service, it's only going to get traffic from France and only for people who are over 13. So this way we can watch this service run, right, and actually start to understand if it's doing the right things and if it's able to scale or make those numbers. The other thing we're talking about is shadow databases. Can I actually accept writes on these copies of services knowing that I may have to roll them back or that I may have to duplicate them somewhere and roll them forward, right? Because you have to worry about data corruption when you start running something for a day if it's not just reads. And really, I think we need all these things, right? You can't just get away with one of these things. I think as we move forward in time, you start to need to answer all these issues. More stuff in the future. How do we scale automatically? You may have noticed a few slides ago, there's this magic number here, right? I actually had to put a number. And this is great, right? It used to be I had to file a Jira ticket to get more servers, and then wait 6 to 8 months or whatever it took to get us servers. We're faster than that, but like you have to wait for servers and somebody to go rack them and install stuff. Now we've got a count, and that's cool, but like, is 20 really the right number? It's not the right number at our troughs, and it might be just a little too short at our peaks, but we don't really know. And this is where you get into like, what does it actually look like to start defining a contract for scaling, right? And again, this is me putting out some ideas about stuff we've talked about, but like, we need this contract at some point, right? You need to start negotiating with your system about how you can scale both up, right, and down. Like, hey, we need at least 3, but like, if the CPU goes over 80, start adding more nodes, right? We need more stuff. And ultimately, as you get more and more of these services, we're running 50 or 60 now, but like, as you get more and more of these services, you need to kind of defer to the system's intelligence to be able to keep building this stuff out. Another thing in the future, how do I deploy continuously? So all this stuff I've shown you right now is really people deploying. There's still this human in the process hitting buttons every time that something has to go out, right? And to get to the next stage, you really have to talk to yourself about your tests, right? Because like, part of the reason we're sitting there is you can like, okay, it passed the tests, but is it really actually going to work? So you have to start generating like a sense of trust in your own tests before you can actually let the system just deploy on your behalf, right? If it passes all the unit tests and it passes all the component tests and then it starts failing, like, we'll all be really sad. And this is where we talk about things like, do I have code coverage? Am I covering all my API endpoints? But also, how am I exposing that? The other thing we have to think about is, how am I handling failures? One of the things that you often see when you're going into production is you run all these tests and they get past unit tests and component tests, and then you're like, okay, cool, that third party is down. Oh, shoot, I didn't write a component test to cover the fact that I couldn't talk to the guy down the way, or that worse, he was misbehaving and only failing 2% of the time, and suddenly like that's cascaded all the way up through the system, right? So before you can actually really get to a spot where you can continuously deploy, you also have to get to a spot where you can like trust that your tests are at least giving you the coverage you need. You also have to start answering this really interesting question, which is, hey, we've added canaries, but how do you promote them? right? Like, what's the metric? Like, are you looking at error rates? Like, if I have version 1 and it's got a 0.1% error rate, and then I deploy version 2 and it has a 0.2% error rate, like, is that okay? Or is that bad, right? Like, am I able to go forward? If I have something that was performing, 400 concurrent requests a second, and then I ship the new thing and it's performing 600 concurrent requests a second, hopefully that's better. But an automated system might also look at that and go, that's really weird. You must be doing something wrong, right? Likewise, an automated system could look at the inverse and go, well, you used to do 600 and now you're doing 4. You must be doing something really wrong, whereas actually maybe you just added functionality and like you know that you've changed it. But really answering this begets this kind of premise of like, how can I describe to the system what type of constraints I want from it? And again, right now, when you're doing this manually, you sit there and just kind of figure it out. You're like, oh, hey, I'm getting less concurrency, but that's okay. We added that new endpoint. I know I'm going to get less concurrency, right? But again, when you start moving to a system where like you have to deploy continuously, you can't just like, you're no longer in control, right? You can't trust your gut, so you have to really trust that you can tell the system how to behave. Another thing we're talking about is multiple data centers and availability zones, right? What does it look like to say that I've got different numbers of instances in the east and the west zone, but also that like they have different response times, right? Because like we don't even necessarily expect them to all behave exactly the same. And again, we get to contracts, right? Like how do you build a contract that lets you manage that? One other thing that I don't think we talk about a lot is how do I price this stuff? Now, a lot of us are running on AWS, right? If you have the glorious benefit of running at AWS, then you know exactly what everything costs, right? Because AWS sends you a bill at the end of every month, and hey, that's what it was. Azure, GCP, it's all the same. Obviously, we're Roblox, right? Everyone's internal. We're all talking to each other. But we don't actually know what everything costs, right? And if you want devs to be efficient, like they need an invoice, right? You need to be able to, even just internally, like, hey guys, you're spending this much money to run the software that you're running, right? But when you get to 25 teams, suddenly like the teams are talking to each other. So if I want other people to use my stuff efficiently, like I need to give them an invoice, right? I need to start like crossing this off and going like, hey, text filtering guys, you're taking too much money, or inversely, hey, I'm filtering all your text, but it's really, really expensive. Like, can we change the way you're doing that? But it's really hard to have that conversation if you don't actually have a way to even figure out how much money you're spending, right? And ultimately, like, I don't know of any good format for this yet. I've been to DockerCon. I've talked to lots of people. There's no real standard for like how do you format an invoice so that services can actually begin to communicate and understand that they're using each other's resources, and then actually be able to push back on things, right? Like how can I communicate to, if I'm the text filter service and you're the person filtering text, how do I communicate to you that like you're just using too much bandwidth, and start to push back and manage those SLAs in an automated fashion. And really the last thing that we're looking towards in the future, and I think this is kind of our constant North Star, and this is really what like Will and I started this whole thing with, was like, how do I minimize the code that I need to write? Now, Will gave you that beautiful picture of like all the, all those blocks of white with all the scaffolding that we put together, but like, when you really drill into it, like why do we even have to write all the scaffolding code, right? Like a lot of our services look a lot the same, right? They all need to know requests per second. They all need to know RAM, CPU, et cetera, right? Or whatever we're using to cost things. But like, why do we have all that? Can I just write the business logic? Like, how much can I get out of the way, right? And likewise, like, why do I need GitHub and an IDE? Like, don't get me wrong. It is cool that we all work on GitHub and that we understand these things. But like, how much of our code really needs to? Like, how often do you sit there and go, man, I really needed that git command or my code would not have worked, right? It's not necessarily core to what you're doing. It's just the thing you need to know in order to get your code shipped, right? So we also talk about like, what's it like to get GitHub out of the way? What's it like to get an IDE out of the way and make your experience developing continuous? And Will always likes to talk about his example of like, can I write new code from my cell phone? Like, what is the difference between, like, what is the distance for me being able to write new code on your cell phone? Now, we may never be able to do that, but I think it's a really important thought exercise, because the stuff that's like getting in the way between you and writing code on your cell phone and shipping it to production, those are the things that are processes we probably want to get rid of. So the future right now is, well, it's open, right? The future at Roblox is yet to be written for all these things. And And they're really hard questions, right? There's no simple answer to all these things. And the thing about hard problems is they're hard. We need to put people on them and think about them and work through them and really come up with the solutions that are going to serve Roblox and our engineers and our community in general.
I got a non-technical question.
Oh, no.
Because I'm not technical, but I just want to have a toy.
Fire away.
Thank you. All the changes that you showed tonight, it's not easy to convince the team to be part of that. So can you share with us what you guys did to convince everybody to be on board?
There's a few versions. I mean, I think one thing is people will run away from pain. So that's always a good one. If you give people something that is easier and better, and like I said, easier means less pain, they will generally take it. So that is one of the driving forces behind our little microservices team is like, let's give people stuff that they want to use, and they will kind of naturally converge on that. Roblox is basically a giant marketplace for user-generated content, and we treat internal stuff as a marketplace as well. Right? It is not unusual for 2 or 3 different things to happen in Roblox at the same time and for one of them to just kind of win out, right? So we have to kind of be open to letting these things happen. But we also have to open our doors. So like Will was talking about, like we run, regular training sessions. We brought in the interns and taught them our stuff and then rewrote the entire docs because we realized the interns weren't thinking the same things we were. And now we're, in February, we're going to start running internal training sessions, like, in a classroom together, programming, and it's opening the doors to people doing things the new way. And Roblox is filled with a lot of driven people, right? We self-organize. Like it's literally on our mug. It's on all of our desks. So empowering people to self-organize is it's how we work. Also on the mug is the term own it. We want people to own it, and people want to own it. That's who works at Roblox, because you want to own a thing and you want to organize the thing. So we're just giving you better tools to do that, and that just kind of naturally pulls people in the direction. Does that answer it for you? There's one other one over here.
I just wanted to know, how do you benchmark your solutions? You can have over 100 million, I guess. What's the upper limit, and how do you figure out how much can you support? And if you have to extend, I'm sure you have like the contracts for increasing the CPU and the memory, but in a production server, say you do a marketing ad, and then immediately, for example, it turns to 500 million or 1 billion users. Would you have to do something, or is it going to scale on its own?
If we got 1 billion users tomorrow from 100 million, we'd probably have to buy some new hardware. I think that would be an absolute given. But on the smaller scale, in terms of part of this, like owning my own code, is actually empowering people to do that. So we actually have a bunch of tools where we can do things like kind of fork some public traffic into new services. So for example, we did this like literally this last quarter. Somebody launched a thing and they were like, can it do 30,000 requests a second? And we went in and flipped a couple configuration switches and turned on a spigot and said like, hey, set up your service, it's over here, you're getting 30,000 requests a second. Now again, they weren't modifying data, but at least we could ascertain like, hey, could they actually handle this? Could they handle the number of concurrent writes? So we were able to do performance characterization like actually in advance. Right? And in fact, that's one of the things we talk about when we talk about test and production. What I was showing, what I was talking about was like what the far future looks like, but even in the early present, even the current day, we've got this ability to start siphoning enough traffic and to start letting people test their stuff, right? So that's how they got to 30,000. We actually figured out what all the problems were and rewrote their app so that it could get to 30,000.
So it's a well-calculated number, and that you guys have.
Yeah, well, the key is to give people opportunities to be able to test stuff in advance. And that's like what I said, like testing in production. The challenge is you can sit there and say, hey, look, it worked. All the unit tests passed. All the component tests passed. But like until it actually gets there and really starts ramping up traffic, you don't know. And that's also why you have to really start thinking about fine-grained tools, right? Because like every zero you add changes the nature of how that thing works. So you can go there and be like, look, it ran at 300 requests a second. You're like, okay, well, we add a 0. Is it going to work? Like, if you've never tested it, like probably not, right? And then you add another 0, and now you're at 30,000, and then you add another 0, and you're like, well, wait a second, like that's 300,000 requests a second, and that's not even our biggest server, right? But like every time we add a 0, things are probably going to break for reasons we haven't figured out yet. So the biggest key is not being angry at people that they're breaking stuff. It's empowering people to have the tools they need to get there.
Right. Just one last question. The source code that you showed, a few commands that spawns up, your service within half a day, and the changes in half an hour or something. Yep. Are you writing like Docker code behind the lines, or what exactly are you doing there?
We're actually, I think it's just a Node. So right now it's a Node.js app. Like it's literally a command line app, but it is generating default versions of all the things, right? So we've talked to the infrastructure team. We figured out like okay, you're building a service. It's called XYZ. What do we need in a Nomad file to make that work, right? And in fact, we've gone through the Nomad file and also set some best practices. Like, hey, if you're going to start up a new thing in production, it has 3 nodes, right? Why? Because it just needs 3 nodes. We can't have less than that.
Sure.
So we've also started to implement that. But a lot of it is literally, like I said, you tell us what type of service you want. Is it going to be a background thing? Is it going to be an HTTP service? And we intelligently kind of go through and figure out what your alerts should look like, what your chart should look like, what your Nomad file should look like, we scaffold out a C# service for you so that you can just fill in the endpoints. And we just kind of do all those things programmatically so that you get all the defaults. Obviously, once they're done, you can go in and add stuff to your charts, right? You add stuff to your charts, you save the file, you check it in, right? Hey, look, it's there now, right? So we're not enforcing the long tail. We're really just enforcing the startup. Like here's the minimum. You must be this high.
Bare bone.
Yep.
Bare bone structure. Okay. Right. Thanks.
Two quick questions. One, I was curious about like a Nomad console and why not Kubernetes, and then similarly, why data centers and kind of staying with that model versus cloud, or are you looking to blend those two?
Oh, wow. Okay. I think I can deal with the first one, but maybe not the second one. The second one's a lot more complicated because we are dealing with some clouds, right? Like it's complicated. But for the first one, literally it was just an internal decision, right? Like some people knew Nomad and we had that expertise, and we went with Nomad. I think it's worth stating, and so I was at DockerCon in April, and I think it was an illuminating experience. I think the interesting veneer over all these things is, you go to DockerCon, they do this demo, and they show you this thing, and you're like, wow, that was really cool, but like, why are you doing it like that? Like, where's the security model? Where are these other things? Like, there's always a lot of questions. And what I found, at least in April 2019, was that a lot of these things were still very, very new. Like even mature technologies like Istio are like less than 2 years old. So when you go talk to people who run Istio or build Envoy, and how are you actually running this? Well, they're like, yeah, well, we've got Envoy, but then we have all this customization over here. We've got Istio, but like we have to do all these things to make it work. And so I think that at the root of it, we picked this container technology or this orchestration versus that orchestration isn't necessarily the biggest thing at this point. I think it's actually just really understanding what those tools are and growing with them, because ultimately you kind of have to build around them, right? Like you're going to have to do things, right? I say we've got Nomad Console Vault, we've got Trafic in there. Like we need to work with all these pieces to make them work together. And as we scale and we start to really understand our traffic, I think that just becomes the norm everywhere. And I say this having talked to other people who've had to do this, right? So when we talk about 17,000 servers, running in production, there aren't a lot of Kubernetes clusters running that size kind of anyways. And anyone I've talked to who has something that big, they've got stories. So I think it's important to understand that the technology isn't the magic. It's the technology is just an enabler, and it's the people who can go in and really understand the technology and use it the way that's appropriate for their cases. That's really the magic, right? It's getting the most out of that tool.
Hi, so your question was why roll our own versus using, say, AWS or Azure or something like that? The answer is pretty simple. By looking into it, we can create a cheaper, better solution both for us internally and for our customers by rolling our own. It's as simple as that. We're creating something that's very focused, bespoke, tailored to our needs, and it's way more cost effective, and then we can take those cost savings and help us drive the business more effectively. That's as simple as that.
You get those swipes, as a platform, I imagine you guys get these kind of
Yeah, so let me just talk a little bit about AWS. We do support AWS. We can burst into the cloud if necessary, and someone asked about how do we deal with scalability. We build our services with scalability in mind, so they can, 2x, 3x, depending on the service, depending on, so if we get a spike, we can deal with it. But if we had a massive spike, then we would burst into AWS and deal with it that way. So we built out that capability. So that's how we figured that out. And we do use AWS. We've got a very large DynamoDB cluster. We have some Redshift that we're kind of deprecating now, and some other bits and pieces. So it's not kind of like we hate the cloud. We're not going to use it. If it makes sense, we will use it. We try to be smart about it. But our general vision and goal is to be in our own data center, because we believe we can control our own destiny about that best that way and provide the best solution to our customers.
Andrew, do we have anyone else?
All right. Well, really, thanks again. Thanks to our speakers and everyone for coming. We have a networking session. We want to hang around a little bit more, talk separately to our great folks here. And thanks again. Have a good evening.